Okay, now we'll discuss on voltage multiplier. Voltage multiplier is an electrical circuit that uses networks of diodes, capacitors to convert a low voltage AC signal to a high voltage DC voltage. It boosts the voltage by charging the capacitors in parallel and then discharging them in series, eliminating the need of heavy, expensive and high voltage transformer. So instead of using transformer, we can use a base simple circuit to amplify your signals. Okay, so there are different type of voltage multipliers. One is called a voltage doubler. Actually, it's will double your input signals. An electronic circuit that produces a DC output voltage roughly twice the amplitude of its AC input voltage. It is a type of voltage multiplier that uses network of capacitors and diodes to set up the voltage without a bulky and expensive transformer. Okay, so this is a simple voltage doubler circuit where we have a capacitor and we are using two diodes. One is D1 and D2, and we also have a capacitor C2, and we are measuring the voltage outside that. Okay, so if you use this circuit, we should get whatever V input is given, the output should be V output. So actually it's based on the capacitor principle. If we are giving a capacitor, that is we already described in one of these previous videos, where we charge the capacitor and discharge the capacitor. So if the discharging time is much longer, the capacitor does not discharge easily, so it will retain the voltage whatever it is. So it will charge a particular voltage and it will act as another voltage source for that one. Okay, so that voltage source will provide in the initial part of the cycle, it will charge to a particular voltage, and the diodes initially, if we are giving a positive voltage, this is not let's see, it's if you are giving a negative voltage, so this will pass to this is forward biased, and the capacitor will charge through this circuit, and this is not a path for this one. Okay, this will charge initially, and for the second cycle this will be not forward biased, and this is forward biased, and the capacitor second will be come into the picture, and we have two sources now. This is V in, and this is the capacitor also will be charged to V in. Therefore we get two times of this voltage. The capacitor will charge to this voltage, and we will get a final voltage of 2 V in from the output side. Okay, that is the principle. Actually, its capaciting effect will help to build a 2 times voltage. Okay, so from this works on the voltage doubler works by charging the capacitor in parallel and the AC source during one part of the cycle, then the discharging them in series during another part, effectively doubling the voltage at the output. Okay, so this is the so if we need more than 2, what to do? So this is, we can consider this is a doubler circuit where we have a one capacitor, 2 capacitor, and we also have 2 diodes. Okay, so if we can extend this same circuit, because 2 diodes and capacitor, so you can actually extend your multiplication. Okay, so this is doubler, and this will again a doubler, like that you can extend to get you can get any type of multiplications. The fluctuations in voltage multiplier is also known as ripple or poor regulations, are caused by the charging and discharging of capacitors and by the circuit internal impedance. While the voltage multiplier is designed to step up an AC input to high DC output, its components cause output to have periodic fluctuations and AC components, and drop the load current increases. So it has a poor regulations here. So if you use these circuits, the output have a lot of ripples are there, so it's not completely a DC circuit. So let's try to implement this voltage multiplications in LTspice and see whether it is multiplied. Okay, let's see, we can so let's simulate your circuit in LTspice. So we have a power supply, which is I have given a sine wave of 20 amplitude and a frequency of 50 Hertz. Then I have a capacitor is given as 0.1 milli, then we have two diodes IN4007 and one capacitor 0.1 milli, and the resistor is given as 100 kilo ohm. Okay, the response is I have given a transient response given a time of 0.5 second. Okay, so if I run my simulations, so I can run my simulations. So if I see our input signal, so this is showing minus 20, so the amplitude we can get it as 20. Then I measure my output from here, so I can see that, so after initial time this will be saturated to about 40 watt, which is double of my input signal. So that's why we are getting double of my input signal we are given. Okay, we can also try to see our voltage multiplier. Okay, so here what we do is we will use multiple blocks of these codes. So this doubler, so let's see what is the output from here. Okay, so if I run my code here, so again, so this is the input we are giving, this is again minus 20 to 20. Then if I try to measure my output here, so I am getting a signal, so this is 20, I am getting about this is about 100 something. Okay, so there are a lot of ripples are present here because of this this method is not ripple free, so we get a ripple here. So if I try to measure before some phases, we can see in each phase there is a multiplication happens. Okay, that's why we get different stages, we get amplified output from the later stages.